Module 2. Characteristics of relation. Relation is a table consisting of rows called tuples and columns called attributes in a relational database. Characteristic: relation has a unique name. Student, employee. Attribute names are unique. USN, name, branch. Each cell contains single value. No multi-valued attributes are allowed in relational database. Values in a column belong to the same domain. Branch column contains only branch names. No duplicate tuples. Every row must be unique. Order of rows is not important. Rearranging rows does not change the relation. Order of column is not important. Attribute positions can change. Relation has finite number of tuples. Database stores limited records. Each relation has a key. Primary key uniquely identifies tuples. USN, name, branch. 101 Ram CSE. 102 Ravi ISE. USN is the primary key. Relations store data in tabular form while maintaining uniqueness, atomicity, and integrity. Basic operations that change the state of relation. Insert adds a new tuple. Insert adds a new tuple, that is insert into student values 103 Sita EC. Violations: key, domain, entity, integrity. Delete removes existing tuple. Delete from student where USN equals to 103. Violation: referential integrity. Update modifies existing value. Update student set branch equals to AIML where USN equals to 101. Domain key, referential integrity. Constraint handling. Reject operation, rollback transaction. Reject operation, rollback transaction, cascade update or delete, set null or default value. Conclusion: insert, delete and update, modify this. Different types of update operations on relational database show referential integrity violation in each case. Referential integrity violation. Update operations are operations that modify the contents of the relation. There are three types. Insert operation adds a new tuple into the relation. Insert into employee values 101, Ram, 10. If department 10 does not exist in department table, insertion is rejected because foreign key value has no matching primary key. Referential integrity violation. Delete operation removes a tuple from a relation. Delete from department where D now is equals to 10. If employees are working in department 10, deleting the department leaves invalid foreign key references in employees. If employees are working in department 10 and deleting the department leaves the invalid foreign key reference in the employee. Update operation modifies the existing attribute value. Update department set dnum equals to 20 where dnum is 10. A referential integrity violation. Employees still referring to dnum 10 will have invalid foreign key values. Methods to handle violations. Reject operation, cascade update or delete, set null, set default value. Set null, set default value, reject operation, cascade update or delete. Insert, delete, update or the basic update operations. DBMS checks referential integrity during these operations to maintain database consistency. Discuss any 4 relational algebra operations with example. Relational algebra is a procedural query language used to perform operations on the relations. Select sigma retrieves rows satisfying a condition. Student USN name branch. Select. So sigma branch is equals to CSC of student. Sigma branch is equals to CSC of student. It will returns all the CSC students. Project pi. This is select is sigma. Project is pi. Retrieve specific columns. Projection operation. Pi name comma branch of student. Specific columns returns only name and branch column. Union combines tuples from two relations. Student 1 union student 2 returns tuples present in either relation. Join combines related tuples from two relation. Employee EID name dnum, department dnum dname. Return employee details along with department details. Join operation. These are the four relational algebra operations. Select, project, union, join are important relational algebra operations used to retrieve and manipulate data efficiently. Select for rows, project pi for columns, union combine relations, join connect tables. Explain entity integrity and referential integrity constraint. Why are they important? Entity integrity constraint. Entity integrity states that the primary key cannot be null because it uniquely identifies each tuple in the relation. For example, student USN name branch 101 Ram, 102 Ravi, valid, null Ram, invalid. Importance: uniquely identifies records, prevent duplicate entries, maintains data accuracy. Referential integrity constraint: a foreign key value in one relation must either match a primary key value in another relation or be null. Department number is 1020. Employee ID is 101 Ram 10. Valid. But if employee 101 name Ram dnum is 30, which is not present in the foreign key as well, because department 30 doesn't exist. A foreign key value in one relation must either match a primary key value in another relation. This is referential integrity constraint. Entity integrity constraint, referential integrity constraint. Applies to primary key, applies to foreign key. PK cannot be null. FK must match PK or null. Ensures entity identification. Ensures relationship consistency. Explain select and project operators with examples. Select operator. Select operation retrieves rows or tuples that satisfy a specified condition. Sigma condition relation. Student of USN name branch. Select, that is sigma branch equals to CSC of student. Displays only students who belonging to CSC branch. Project operation operator pi. Project operation retrieves specific columns from a relation. Pi attribute minus list of relation, list, and then the relation attributes list. Whatever the attributes you have to want to retrieve, you can do that. Project operation retrieves specific columns from a relation. Pi attribute list relation. Example, pi name comma branch of student displays only name and branch columns.